So in Lab 2, you're going to be studying some debugging tools. These help you hunt down problems in your code. So it's unfortunately just a reality of coding that when you try and create a program, you often find things don't work at first. So maybe it doesn't compile at all and you get a bunch of error messages. Or maybe it compiles but you get warning messages and it doesn't quite behave the way you expect. Or maybe it compiles just fine, but it doesn't do what you intended it to do. So the debugging tools that you've got access to in the MP Lab program are useful for hunting down what may have gone wrong and figuring out how to fix things. So to begin with, there is a suggested pre-lab for this, and that is just to read Appendix E on the simulator in your lab manual. Now, the first part of the experiment, you are going to be creating some functions that allow you to display integers as binary. So most C compilers actually allow you to do this, that you can just take an integer and display it in binary. Unfortunately, XC8 compiler, which we're using, does not allow you to do that. So as usual, on the website, you've got some files, so you grab those, and you've been given a function here that allows you to print a character, so data type character, as a binary number. And then you create your own function, a second one, that prints an integer as binary. And then you're going to make a library of these sorts of functions that allow you to print off integers in binary format. So like last time, you make your own library of functions that you can then refer to in future labs as needed. So you've been given a function, print car as binary. That's located in a file called binaryformat.c that you can get off the website like normal. And if you open up that code and have a look at it, you'll see that the print car as binary function has all of these if-else statements, a big string of them. So I want to just briefly go through the logic of how this all works. So number is some number that you are inputting into the function, and that gets ANDed into another number. This number over here is called a bit mask, and you'll notice that our bit mask is all zeros except for this one bit, which is a 1. So what happens when you AND this bit mask into some other number? Well, that's what I've done down here. I've got some number that I just made up, and then I'm going to AND it into the bit mask. So remember that an AND operation consists of looking at the two numbers, this one and this one to begin with, and saying, are they both 1? So is this and this equal to 1? If the answer is yes, you'd have a 1 down here. If the answer is no, then you'd have a 0. So is this and this both 1? No, so I get 0 down here. Likewise over here, is this and this both equal to 1? The answer is no again, I get a 0. Is this and this both equal to 1? In this case, it's a yes, so I'll put a 1 down here. And you'll notice that because our bit mask was all zeros except for this one bit, that means I'm going to have zeros everywhere down below. This one bit here is the only one where we had a possibility of getting a 1. All of the rest of them must be zeros, so I'll plug those in. Now, if this digit right here had been a 0, we'd have 0 down here also. Because it's a 1, we've got 1 down here. So the bit mask is essentially allowing us to pick out one bit of the original number and preserve what it was. Everything else gets discarded, but we've preserved what this one bit was. Great, so why do we want that? Well, let's have a look at the code again. So after we've done the AND operation, the next thing they do is they apply what's called a bitwise shift. So that's this double chevron here. So they're saying, take this number, the outcome of the AND operation, and just shift everything over by 5 spaces. So that means we're going to go 1, 2, 3, 4, 5 over. So we're going to preserve these 3 digits. I'll type them down here, 0, 0, and 1. And the rest of it got discarded. So these bits all got discarded. The program will fill in the rest of these, pad the rest of these as zeros. So we took one bit out of the original number, we preserved what its value was, and then we shifted it over to fall into the location of the smallest bit. And then the very last bit of logic here is just to test whether this was a 1 or a 0. So if it's a 1, the program prints 1, and if it's not a 1, then it prints a 0. So again, if you go and look at the code for that print car as binary function, you've got a whole bunch of these if-else statements. And what they do is they just go and look at each of the bits individually in the original number and test whether it was a 1 or a 0, and then print 1 or 0 as appropriate. Next, you'll be looking at the simulator, and to do this, you look at Appendix E, and I will note that for both the simulator and also for the watch window and the stopwatch window, when you're going through Appendix E, it gives you a very nice, complete explanation of how to actually invoke these things. You might want to, as you're taking notes, come up with sort of a short bullet list of how to do these same things, and then consider putting that in the back of your logbook just as your own appendix so that you can quickly refer to it when you need to. So you'll be running a project from Lab 1 in the simulator and observing the output that it gives you. In the next part of the experiment, you're going to be playing around with watch windows and stopwatch windows and using breakpoints, which are just a point where you stop the code in the simulator, and you can look at your variables in the watch window, for example, and see what values they have. So that allows you to check whether your logic is working, for example, if you're getting the values you expected to get at the moment you expected to get them. So one of the things that they ask you to do here is to open a watch window, and there's some binary operations that are taking place there. They take two numbers and they AND them together, or they OR them together, or they exclusive OR them together. They apply these operators, and you're supposed to check whether the answer you're getting actually corresponds to the answer you expected to get. So I'm going to just go through very briefly how you do this. So in the program you have A and B, and you're going to be calculating C. And there's a variety of logic operations that could be applied. So it might say A and B, or A or B, or A exclusive or B. And you need to check whether C, the value that's being calculated, is actually equal to the value you expected to get. So let me show you how you would confirm an OR operation. So that's the symbol for OR. So first of all, display A, B, and C as binary numbers, not as decimals, because you want to check things bitwise to see whether the logic operation is satisfied. So A or B means, is this one or this one equal to 1? And in this case, one of them is equal to 1, therefore our answer will be true, 1. In the next bit over, is this one or this one equal to 1? No, so the answer will be 0. Is this one or this one equal to 1? Yes, so the answer is 1. Is this one or this one equal to 1? Both of them are 1, so the answer is 1. And you just check each of these. So this bit and this bit, one of them is a 1, therefore A or B is true. Again, this will be true, this one will be true, and this one will be true, because all of them have at least one 1. So this right here is what we expect C to be. So when you're confirming the bitwise operations, the program has a value for A, a value for B, it calculates a value for C, and you check whether the value that the program is giving you is equal to what you expected it to get. So in the next part of it, you're going to use the stopwatch window to, for example, time how long it takes to do an operation if you're using data type character or data type integer. And you'll use a stopwatch to also time how long your delays take. In part C, you're going to be debugging some projects that we give you. So it explains to you how you get those. You download your files off of the website as usual and unzip them. And you're going to open up each project and build and run, or attempt to build and run the code and see what happens. So what's going to happen is that you're going to find that there are a variety of warning messages or error messages. Sometimes the program will build, sometimes you'll get a build failed message. Sometimes it'll seem to build just fine with no errors or warning messages, but things won't behave quite the way you expect. So for this part up here, you're just going to look at the error or warning messages. So you'll go through each one of the different debug projects that we give you and figure out what the error and warning messages mean and how to fix them. In the next part, you actually will have to look at all those projects again, because once you've gotten rid of the error or warning messages, that's not a guarantee that those programs are actually functioning the way they are supposed to. So for this part of it,
you use the stopwatch and the watch window and you check whether the programs are actually doing what they're supposed to be doing. So if you read the comments, it tells you what that program is supposed to do, and then you can double check using your watch window to look at the variables or the stopwatch to check the timing, whether it's actually doing what it's supposed to do. And most of them will have a problem, and you can figure out how to fix that.